next speaker. So it's my great pleasure to introduce to you Partha, who is right now a research scientist at Google, as well as still a professor at IISc in Bangalore. And Partha has done a lot of work in this space and beyond. He actually wrote books on graphs, so he really is one of the main players in this space, in particular in the space of modeling temporal aspects of knowledge graphs, which I think has been a question that has been ignored or not getting enough attention for quite a while. But I think Partha changed that for the better. So I think without further ado, let's hear from Partha.
So we'll do the presentation. Okay. Good morning, everyone. It's great to be back at AKBC and that too in person. And thanks, Sebastian, Andreas, and Jonsol for having me here. So today I want to talk about two specific aspects of knowledge graphs. So one around time, as Sebastian mentioned. And although the title kind of talks about multilingual, but really the topic I'm interested in is the inclusivity and how we can bring in more inclusive knowledge representation. So some thoughts around both of these two topics. So whatever I'm going to talk about is a joint work with a bunch of people, both at Google and outside at IIT Bombay, IISc Bangalore, and IIT Delhi. So to keep the motivation short, the world is dynamic and diverse. So lots of things change over time. Everything is changing all the time, right? So if you are say a journalist wanting to write about the fire in the tube today morning, right? So you want to know what kind of events led to that, what were the sequence of events, or people change jobs, in a person's life, lots of things change. So the world and the entities therein are constantly changing. And then we also have lots of diversity in the world, right? So when we think about or traditionally about knowledge graphs and knowledge representations, even in our research, we tend to start with English, and it's an English-centric view. But there is lots of diverse knowledge in the world. So the question is how we can make knowledge graphs capture this dynamism and then also be inclusive at the same time. So that's the motivation behind the two parts. So I'm going to divide the talk into those two aspects, one around time, and in particular, how we can do question answering by taking time into consideration. And the other one is how we can move towards a more inclusive knowledge base or knowledge graphs, which captures different knowledge from different regions and languages. So the first part, so how are we doing questions, by the way? Interactions are okay, or at the end? Okay, yeah. So then, if you have any questions, please feel free to stop me at any time. It doesn't have to, you don't have to wait until the end. Sure, yeah, maybe they can raise hands there. Okay, so hopefully we are good with the motivation, why we should care about time and inclusivity. So let me start with the time aspect. So looking back at time and knowledge graphs, I started thinking about time about 10 years back. So I was part of the NEL project at CMU, where we were looking at how by reading web documents on a continuous basis, we can build these kind of knowledge graphs. But at that time, the edges in the knowledge graphs or the fact triples, they didn't have any timestamps associated with them, right? Or even the knowledge graph that the NEL model was learning, it was all static in some sense, but that's not reflective of the world. So we did some work on how we can assign timestamps to those facts in the KG by again posing this as a reading problem and then doing some sort of constrained inferences on top of it, right? So there the idea was that okay, that a person needs to be born first before they can become a president. So how you can enforce those learn those constraints and also enforce them. Just another sample of work was back around like 2018. Already by that time there were lots of work on link prediction, knowledge graph embedding. But then again, by the time there were starting to have knowledge graphs which have these kind of temporal scopes in them. So the question was how we can also take that time dimension into account while doing the knowledge graph embedding. So we had a model called HiT. And then after that, we kind of started thinking about how we can do reasoning or even question answering over these kind of temporal knowledge graphs. And that's what I want to talk about today. So just to make sure we are all on the same page, when we are talking knowledge graphs, so we are basically talking about our regular binary relation for today's talk. So these binary edges where everything is kind of like the regular knowledge graph, but then we also have the timestamps associated with them, right? So you can say okay, Donald Trump was president from 2016 to 2018. So you can have those two additional tuples or two additional dimensions, which is the start time and the end time. So you end up with a fact with 5 tuples here, right? So this is my view of temporal knowledge graphs for today's talk. And the question is how we can do question answering on top of this, right? So type of questions could be say, when did Trump become the president of US? Or who was the president of US after the Second World War, right? And people are interested in these kind of questions. And if you look at say natural questions, which was kind of based on actual questions that people ask to web search engines, you do see these kind of temporal questions being there. So it's not a made up problem. So, but the question is how we can do this on top of temporal knowledge graphs. So, so we were thinking about these problems around say 2019 and 2020, but all of the pieces were not in place. So one was that there were already by that time there were lots of work on doing question answering over knowledge graphs, which is the KGQA problem, both for single hop and multi-hop reasoning. But all of those things were on the regular knowledge graph. So the static knowledge graphs without the timestamps on the edges. And then also appropriate data sets were not present, right? So there was not much of a good coverage benchmark data set, which have these kind of temporal questions. And then also they operate over a temporal knowledge graph. So please note that there are these two parts, right? So you have the questions, you have the knowledge graph, and we are looking at both of them being temporal, right? So in this work in ACL 2021, so we basically proposed a new data set, and I'll talk more about that subsequently, called cron questions, which has about 410,000 question answer pairs defined over a temporal knowledge graph, which was like a subset of Wikidata in our case, and then also proposed a method called cron KGQA, which does this kind of temporal question answering over the temporal graphs. So I'll talk about both of these two aspects and give you some flavors for those. So the cron questions data set, we started off with a subset of Wikidata. So Wikidata is probably the largest and fastest growing open knowledge graph, kind of like a sister version of Wikipedia, but of course there's a lot more structured knowledge there just compared to the documents in Wikipedia. And yeah, so we basically, after doing some cleanup, ended up with a version of the temporal knowledge graph which had about 125,000 entities and 328,000 facts. So we defined a few handcrafted templates, 30 of them, to come up with these kind of questions that could be kind of induced over this temporal subset, where things are say simple time-related questions. So when did a person or the head of a triple kind of hold a position which will be the object? then simple entity-based questions, before and after, who was the president or prime minister before someone else or before a particular event, when did a particular player play their first game, and so on and so forth. So with these templates, so we used subsequently both human and machine-generated paraphrasing to add some more diversity to that data set. And finally, we ended up with 654 question templates, which we could then instantiate over the temporal knowledge graph, which we built in this first step to create the final data set. So, so compared to other related data sets at that particular point of time, this was significantly larger. So the most relevant previous data set was this temp questions, which had about only 1,200 questions, and that too was not defined over a temporal knowledge graph. This was like a temporal questions, but operating over a regular static knowledge graph. And then here are some examples of these 5 different types of reasoning that you would need for this particular data set. So that's about the dataset part, but before going into the method, which is the cron KGQA, I just want to lay some background in terms of KG embedding and temporal knowledge graph embedding. For this audience, I guess this will be all a very familiar material, but just to make sure we are all on the same page, I just want to take a minute to describe this, right? So in case of KG embeddings, our goal is that given these kind of triple subject relation object, we want to learn some representation for these entities and relations. They could be say vectors, matrices, tensors, but let's say that we are interested in learning some representation, let's say vectors for each one of them. We end up defining some sort of score, which is the phi function here, which is giving high score to triples that we observe, that we assume to be true, and then low score or 0 score to say triples that we assume is incorrect, all right, so, or the negative samples. And then you pose that as a learning problem, and then given a graph and then this KG embedding method, you end up with, let's say, if you're using vector-based representation, then vectors for each one of these entities and relations, right? So there's explosion of work that you're probably already aware, over the last last few years, and lots and lots of methods for doing this type of KG embedding. So most of the variations are in the design of this phi function, what kind of scoring function you're using to do this learning. So temporal KG embeddings basically extend this type of KG embedding methods to the temporal space, right? So where instead of just having subject relation object, now you also have 1 or 2 time instances. So even if you have a span, right? So you can always break that span, temporal span, into multiple, say, discrete time points, and then you can kind of define this type of triples along with a particular time when that particular triple was true, right? So say AKBC 2022 happened on say this particular, today's day, this will be a positive instance, and then say yesterday it will be a negative because the event had not started then. So similar story as before, where you kind of just want to learn these embeddings for not only the subject, relation, and object, but also for these temporal components, let's say, the time instances. So there is some discretization happening here. Maybe we are operating at a year granularity. So even for this time t, now you will start to get embeddings out of it, right? So again, the high T problem that I was mentioning earlier was one of the earlier efforts of that kind. But over the last couple of years, again, more work has happened. And one of the more popular ones is called this T-complex, which came out in ICLAIR 2020, which kind of works in the complex space and then gives the embeddings for these entities, relations, and also the time. And in some of the subsequent work, we'll be using T-complex as a starting point to get embeddings for the knowledge, objects and also the time as a starting point. for initialization. So any questions so far? Yes.
Yeah, I was wondering, does this mean that you have to determine which timestamps are valid in advance?
So that you assume that your knowledge, the temporal knowledge graph is already giving you, right? Because it's telling you that, like, say Barack Obama's presidency, like, happened from, like, say 2009 to 2016. So that's given, right? But here we are assuming, so if this methods requires say, some discretization of that time span, so you could say like, okay, I'm going to work at like a year granularity or month or whatever you decide, and then you're going to learn embeddings for each one of those discretized
for each year or each month. So you need to know where your time stops and ends.
Yes. So the knowledge graph is going to give you that, but that discretization you have to.
Yeah, but your questions might be about things that are outside the scope of your knowledge graph, right? Maybe things in the future or things further in the past, or at timestamps in between that weren't in the necessarily stated facts, but maybe somewhere, in 352 years ago, which didn't have a fact itself. But
yes, yeah. So you hope that, like, you are going to learn those kind of temporal modifiers that's there in the question, which will tell you, like, okay, for a given fact, if I'm saying before, then you should be looking for time spans before that particular, particular fact, and not after. Right?
Okay. Yeah. Thanks.
So you need to, ultimately, when we go into the question answering side, you need to know about the temporal interpretations for the questions, and then also for the knowledge store itself. So right now we are talking about the knowledge store and how we can learn embeddings in a time-aware manner. Any other questions? Yeah.
So for this data set, are we looking at questions which are referring to the global timestamp, or can it also be relative?
What do you mean by relative? So there will be, there will be, so you will be talking, say, asking questions with respect to, say, other events, right? So like, say, who was the US president immediately after World War II, right?
Okay.
So you will have those kind of relative questions as well, if that's what you meant.
No, I was referring to, let's say, if I ask who was the president 2 years ago. So, like, I need to know what is the year right now and who was the president 2 years ago. So
right. Yeah. So I think you can have, like, say today's time as like a metadata, right? So, and then you are kind of like, doing, say, reasoning or calculating shifts with respect to that.
Sure.
Yeah. But that's a very valid question that you expect a temporal QA system to address. I think there was a question behind.
Yeah. So just a small question about the negative samples. So you're only corrupting the temporal part of you're not corrupting SR or O, just the temporal part to create the negative samples.
You could do kind of like both, right? So where you say that, like, okay, a particular fact kind of like existed, but they existed in a particular point of time. And then outside of those times, that will become a negative instance. And then the other thing is, like, some SRO prime didn't actually occur together at any time, right? So all points of T, doesn't matter which T it is, it's going to be negative, right?
Yeah, but for the goal that you have in mind, which one are you going for in negative sampling?
So that's, again, is a kind of like a design choice that you have, right?
I see.
Yeah, so this is kind of like a no single answer, I would say.
Okay, thank you.
Okay. So,
Partha, one more question from the online audience. So the question is, how granular can these timestamps get? Like, would you have like one embedding per date and end time or something like that?
Right. So I think, as you kind of like become more granular, you're going to increase the number of parameters in the model, right? Because now, say, if you're doing, like, say, year granularity, ultimately for each, if say day granularity, for each day you are going to have learned this kind of like an embedding, so that's going to increase the number of parameters. So it's a question of how well you are able to learn those given the available data that you have, because now you're like, you could potentially overfit very quickly. And then the other question is, like, whether you need that type of granularity for the type of questions that you want to address afterwards, right? Because if you're, say, by doing lots of work, you are still learning at a day level, but then your questions are at year or multi-year level, then there is going to be a mismatch then.
That's a very inefficient representation. Like the 3rd of November and the 4th of November clearly very close, don't these models try to kind of add some inductive bias on, proximity or some ordering between these
yes,
seemingly discrete?
Right. So, I mean, even if you don't kind of like impose those things like very explicitly, I mean, you could, I mean, we have seen that it learns some sort of kind of like structure, but of course you can always add like additional constraints of that kind to like, maybe run some like regularizers on top of those. Yeah. I don't know whether explicitly that has been done, but some of those are earlier like non-KG embedding work. So there we tried like learning those type of constraints and then putting those as well. Yeah. Okay, so that was kind of like the background on the KG embedding and the temporal KG embedding. So the cron KGQA basically like works it two steps. So this is an extension of previous work that the Saxena et al. Kind of like did previously, which was on non-temporal time KGQA. So here, what it does is like given a temporal KG, you basically apply methods like say T-complex, and then you learn these embeddings for all of these the KG components, and then you are also given a particular question. You learn some sort of embeddings for that particular question. You have projections of that particular embedding along an entity or a time dimension. So the assumption here is that like the answers are only going to be about like say entities or about time, right? And then you do some sort of scoring across these two like entities or time-specific embeddings, if you may want to call it that. And then you score across like candidate entities, and then finally come up with the final answer. So you basically come up with the entity scores and then the time scores by utilizing these entity-specific projections of the question and then the time-specific projections, right? And then the initializers for all of these things are coming from the, say, T-complex if you use as a temporal KG embedding method to begin with, right? So it's a quite fairly simple system which kind of like learns these question embeddings, and then given the temporal embeddings kind of like learns to score those in a supervised setting. So what we found was that in these cron questions we had two types of questions. One was like simple questions. So these are questions where single hops are usually good enough to answer, right? And then the complex questions are questions which require like say multi-hop reasoning to be done. So what we find is that overall, so cron KGQA does better than these other baselines, including these like T5 based baselines, but there is significant headroom for improvement in especially in the complex questions. So this was like 2 years back. But over the last 2 years, again, there has been like a significant progress on this particular data set to the point that like some 77% of the relative error has been reduced, right? So going all the way from like say 64, 65 in cron KGQA to this tempo QR system, which was like say 92 or so, right? So yeah, so lots of progress in this particular thing. But then again, I mean, there are some also like limitations of the data set, which was that in cron questions, we had like only like 5 relations of interest. And then sometimes like, you could kind of like bypass the whole temporal part because like, the relations themselves didn't require like, knowledge of the temporal part. So we are now looking at how we can create like, a more challenging version of that. So one of the more recent systems in this temporal KGQA is this system called Exact from Gia et al. From Gerhard Wakeham's group, where they utilize graph convolution networks. So in particular, relational graph convolution networks to do this kind of question answering over temporal knowledge graph. So what they do is, given the question, they basically select a subgraph from the temporal knowledge graph, and then do like a relational graph convolution network on top of that selected subgraphs to come up with the final answer. So, but this was kind of like, this was effective, but they had like, lots of like very specific components for this particular problem for the temporal KGQA. So one question that we asked recently is that like, whether we could simplify some of this machinery, and the answer is yes. So I guess that's how this temporally weighted RGCN kind of like work came along. So RGCN is basically, I mean, you probably know about like graph convolution networks or graph neural networks, which are these like ways of learning embeddings for nodes or subgraphs in a graph. And then the RGCN is the relational counterpart of that, where you also take the relationships that's there on the edges in the graph. So, so here in the temporally weighted RGCN version work that we looked at, so here the idea is that not all the edges in the graph, even in a subgraph that you're considering, is equally important. So if I ask this question, who was the first president of US during World War II? So now only like, edges which are kind of like roughly happening around World War II is of importance, and not kind of like, say facts that happened in 1910 or 1800s or even 1980s, right? But the issue also here is that no one is going to give you this kind of like, when this World War II happened, right? So you have to do kind of like this one more hop to get that particular information. So the question is how we can learn all of these things automatically so that we can weigh the edges in the graph when I'm applying this kind of RGCN model, right? So that's what is happening here. So let's say that like things or facts that happened between this World War II period, say from 1939 to 1945. So we want to assign more weights to those edges compared to, say, facts that happened like, much before, right? And of course, these like before, after, during, all of these qualifiers is also going to have an influence on what type of edges you are going to put that emphasis on. But then rather than specifying all of those things upfront yourself, you expect that the model is going to learn all of these weightings automatically. So that's what we are trying to do here. So this is what the overall architecture looks like. So it's fairly simple. So given the input question, we first learn some embedding for that particular question. You could use whatever encoder you are interested in. Then we have a time-specific projection of this particular question. So QB is the embedding for the question, and then QT is the question time embedding. So it's kind of like learning at what time period basically this I need to know about to answer this particular question, or what time period this basically question is asking about. So that's what this particular vector is. Then we also have a gating mechanism to learn whether the answer is going to be like an entity answer or a time answer, right? So that's what this the scores after this gating is going to kind of like tell you. This is saying that, okay, the answer is going to be an entity answer, and then this 1 minus this gated score is basically saying that, okay, no, it's not entity, it's going to be a time answer. So by combining all these three different components, so one is the time-specific prediction, which is given by this vector HTQ, and then similarly like an entity-specific prediction, and then the original question itself. So by doing weighted combination of all of those, after some normalization, we end up with like a composite embedding for the question, right? Now this question embedding is now getting scored across those different entity and time embeddings that we have, and then based on the maximum score, you basically come up with the final answer, right? So, so compared to the exact system that we saw earlier, it kind of simplifies a lot of these very kind of specific components or modules that were present in exact, and it just uses pretty straightforward RGCN formulation to address this problem. So one question is that how do we get this edge modulation, and what this edge modulation itself is. So here is like a one-slide introduction to relational graph convolution networks, where you can think of as like, the messages are getting passed over the graph while we are trying to learn embeddings, say, for the nodes, and then you are doing aggregation for all of the neighbors. So this NR is basically an embedding for the nodes for a given neighbors of a given node, but in a relation-specific manner. So all this, the additional thing we are doing is that we are adding a question-specific weight on top of that, right? So we are saying like, okay, how important is this one particular edge and its contribution for this given question and that given time, right? So question and time specific. And I think this is the one of the 2 slides with math. So after that, there's not going to be any more math there. So here basically the question is now, how do we learn this kind of like time and question specific weightages on the edges? So here we are trying to formulate, so given this kind of question time embedding, which is this vector that we saw here, whether it overlaps in any way over the start and end time of a particular edge, right? So, but all of these things are happening in a vector space, because vectors is what we use to represent these time instances. So we use kind of like 2 versions here. One is the cosine similarity between the average of the start and the end time and the question time, right? So remember, the problem we are trying to address here is whether a given edge is temporally relevant for the question or not, right? And for the questions, I have this automatically inferred time, which is the QT. And then for the particular edge, I have the start and the end time. And now I'm just trying to find some mechanism to do some scoring to calculate that relevance, right? And then we do 2 versions here. One is this average, and the other one is this interval based. And again, like, you could try many, many different other possibilities. And this is just the 2 that we have tried. So, so for this particular paper, we work with this time questions dataset, which again has these kind of like 4 different types of questions, and we find that compared to exact, this temporally weighted method is actually able to do better, going all the way from 0.57 to 0.6 or so. And improvements across kind of like all these different subtypes of questions that's there. So in summary for this first part, so I kind of highlighted the need for doing temporal question answering over temporal knowledge graphs. I presented one data set called cron questions, a method on top of that called cron KGQA, and then also showed finally this, using these kind of like edge weighting methods combined with RGCN, where we can kind of like, build fairly simple methods for temporal KGQA. So a lot more work needs to be done there, because you see that there is, at least on time questions, there is significant headroom for improvement. So it's up to your creativity. Yes?
Yeah. Could I ask a question here? I was wondering, what you would describe as the pros and the cons of this kind of approach compared to rewriting the natural language questions into some kind of query language that would answer them exactly?
Right. So there is, there is kind of like, work on doing these, like say, text to SQL type of mapping. But I don't know whether for this type of thing any work has happened, at least for like keeping time as a first class consideration. So I'm just kind of thinking about, it will also depend on how much of these qualifiers that you're adding, how complex they are, and whether they are easily mappable.
You mean the qualifiers in the questions, or the qualifiers in the data representation?
In the question.
In the question.
Because because the data we are assuming it's kind of fairly simple, where we have
because this was about artificial data, right?
No, your temporal knowledge graph is like real data.
Yeah, but the questions themselves were created from templates.
We created, not in time questions. So time questions was kind of like, I think, like manually generated questions. And they utilize some existing temporal questions data to put together to create this data.
Yeah, with
But cron questions was the template based automatically generated.
Okay, yeah, yeah.
Yeah.
Hi, so I have a clarification question regarding the twin RGCN model.
Yeah.
So in that model, you are computing a question embedding, which is time sensitive, right? So is that relating to
The question embedding itself is not time sensitive, right? So because there we are using like a standard non-temporal encoder, in this particular case, BERT, right? Or not explicitly kind of like, time encoded, but then we are learning this projection matrix to learn the time interval that's of interest to the question, right? And then trying to align that with the edges in the knowledge graph to determine the temporal relevance.
Sure. So basically, this question embedding captures the time information at an aggregate level.
Right. So the question embedding kind of like, encapsulates everything that's there, and time is kind of like one of the component. And you can say that like, from this overall composite representation, we are partitioning out the time part through this particular step, right? So QB is kind of like everything, and then QT is the time part of the question embedding. Okay.
Sure.
So if there are many questions, we can take up offline as well. Yeah. So I will. It looks like I only have 15 minutes. So I'll move on to the the inclusive, the second part, which is I think is like super important, but we as a community are not paying as much attention to it, and I want to see if we can change that. So one question is kind of like why inclusive, right? So we have more than 7,000 languages in the world. But right now, language technologies are available only for about 200 or so, right? So that's kind of like 3%. I think there are some statistics like for about 2 billion population in the world, we don't have any support in native languages, language technology support for so 2 billion out of 7 billion population that's there. And KGs are increasingly I think already there is that it's a super important component for language technology, be it your personal assistant or query understanding, summarization, QA. These kind of external knowledge sources are super important. So if our knowledge sources are not inclusive, then these kind of downstream NLP tasks are not going to be inclusive at all, right? So I think we need to do really better here. And Wikidata, which is, I mentioned, is a prominent open knowledge graph that supports about 550 to 600 languages. But while the statistics might still look good, that okay, we are around say 10% or so, but the problem is that there is some severe skew, as I will show in the next slide. So the point here is that KGs are super important for language technology. And in order to build inclusive language technology, we need KGs to be inclusive as well. So taking Wikidata as an example, so I don't know whether you can read this say one snippet of Wikidata. So there you have this notion of a label. So that's kind of what's the name of the item that's being represented in that Wikipedia entry. Then you have item identifier, which are say unique ID, and then you have description, which is say one-line description of what that particular entity or item is about, and then you have these aliases, right? For all of these three things, label, description, and aliases, you also have associated language codes associated with them, right? So you can kind of go to Wikipedia or Wikidata, and then you say okay, for this particular item or entity, this is a language description in English. I can put another language description in Hindi or Dutch or whatever, right? So, so in the next 3 slides, I want to show you what that language distribution looks like for Wikidata across these three types of objects, which is the label, description, and alias, right? So this is not your eye test here. So I don't expect you to read these x-axis labels, but the structure in all three of is the same, right? So where you have some languages which are kind of very well represented. So as you could imagine, the leftmost one is English, but there is a sharp drop immediately after that, right? So so then the question is kind of how we can make things better, and all of these things are important components, because if you have good aliases and coverage in different languages, then that kind of helps improve your entity linking system, because your entity linkers could benefit from having these kind of coverages. Yeah, yeah.
Fourth aspect, on the graphic, cultural coverage, so the items themselves, I assume are kind of mostly US centric, right? So it's not only the language, but also what are the items?
Yes. Yeah, absolutely. Yeah. So that's my next slide, right? So yes, absolutely. That's kind of two parts. So one is the sparsity in the entities themselves, right? And those entities, if you go to different regions, new concepts, new facts are there. So we need to cover that. So that's kind of this expansion along regions and languages. And I'm kind of using region and language as interchangeable here, right? So that's kind of the pure coverage of more new facts across regions and languages. And the other one is how we can do this kind of more seamless linking between this structured knowledge and text, where there could be language differences on the two sides, right? So those are the two at least sub-problems. Probably there are others which I feel that we need to address as a community to make KGs more inclusive. So so I will kind of describe some work that we have done on the cross-lingual KG text linkage, and then leave you with some thoughts on the expansion and coverage of absolute or coverage of new entities and new facts. So on the cross-lingual KG text world, there is some work on doing multilingual entity linking, right? So so in case of this work by Jan Botha et al., so they developed this multilingual entity linker in say 100 languages, and then there was this work on mGenre, which had an autoregressive model for doing multilingual entity linking. But this problem of multilingual fact linking, where given a particular text, you want to associate what facts are associated with that particular text, was not kind of addressed when we started looking at this. So we basically combined ideas from these two, where we do this kind of a retrieval-based method. Okay, but before going into the problem, maybe I'll just kind of motivate again. So earlier, the distributions that we looked at, those were all at entity level, right? But this particular plot is showing you that similar skew exists even for fact, right? And then a distribution of this fact labels. So you can roughly think of this as just in how many languages a particular fact is present. So again, for English, German, we have a good coverage. But then if you go to, so in this particular case, we are focused more on Indic languages. So you see that there is a very, very small number of facts that are present in those languages. So the question is how we can do this cross-lingual fact linking, where the KG facts could be in one language, let's say in English, and then your text is somewhere else. So we proposed this method called RefCog, so which stands for retrieval, enforced fact linking and constraint generation. Yeah, something like that. So where we basically have a dual encoder model, which given a particular text retrieves some top K facts that we think the model thinks should be relevant for that particular piece of text. And then starting with those retrieved candidates, there is a generator which basically ultimately generates the facts that should be linked to that particular piece of text. So compared to, say, retrieval plus classification type of setting, so in that kind of setting, so the classifier is always stuck with whatever choices or errors were made by the retriever, right? But now that you have a generator here, so there is a possibility of recovery from some of those retrieval losses, but assuming some relevant facts and snippets were retrieved by the dual encoder in the first step. So again, when we started working on this, this was a new problem, and we were looking at kind of more specifically in the Indian languages set up there. So again, no data set was available. So we created a multilingual data set covering English and 6 Indian languages. So this is an evaluation-only data set. So that has around 6,400 test examples covering a knowledge graph of 4.6 million facts. And the input, the data set would look something like this. So you have an English sentence. You have a manual translated sentence in one of these 6 languages. And then you also have the associated facts and the spans of those fact entities, relations, and all in the sentences, right? So while we did this for multilingual fact linking, but if you're interested in multilingual entity linking or relation extraction type of problems, this data set should also be useful. So quickly, when we, so the RefCog model had these 2 components. So one was the retriever, the other one was the generator. So individually, both of them are not good enough, but if you put them both together, then you do better. But then again, there is lots of headroom for improvement here. So all the code and data, everything is available. So you can get it. So the data is available from, but all are online. So that was all about how we can do this, this cross-lingual linkages better. But then how we can go about improving the KG coverage itself. So I'm not sure, when we are looking at deep inclusion going towards lots of different regions and languages, whether pure automated methods themselves are going to be sufficient, because in many situations we may not even have corpus to begin with, right? Or the text corpus will not be there. Maybe we have to go multimodal. But I think whatever methods we have there, I think a community participation is going to be super important, right? So one question is how we can devise methods and incentive structures to kind of engage with communities better, so that this coverage of these knowledge graphs and are significantly expanded. Transliteration is a problem that often doesn't get enough love, but it's super important, right? So transliteration is a problem where you are kind of, you're not translating, but you're changing the script, right? So you're going from, say, a particular word like, say, CBI, and then you are writing it in a script of a different language. So this is, again, is important for improved linking. How we can develop, say, transliteration systems for many languages and scripts. There's also been some recent evidence that by posing things in a multitask setting, especially for low resource languages, posing this as a multilingual multitask problem is helpful. So I think doing more there is important. And then also, we have as a community done lots of work on link prediction, but on some benchmark data sets like, say, B237K, the progress has been quite modest over the years, right? That's what I've kind of put here. So I'll maybe kind of doing a rethinking of how we can do much better link prediction to improve the coverage over the existing knowledge graph itself. So, okay, so very quickly, we have knowledge graphs, and then we have language models. One way is that we can think of these as 2 different stores of knowledge. But one question is what can LMs do for KGs? So definitely with these multilingual models, I think they are going to be very effective, as we have already started to see evidence that to build these kind of knowledge graphs, especially for low resource languages, I think they can do a tremendous amount of job or help in terms of doing cross-lingual transfer of knowledge and supervision. But of course, we need to be care about the fairness and bias issues when we are doing this. But the second question is that, like, in the era of language models, do we really need, like, separate structures to be there, right? But my current assessment is that I think we need structure. Sebastian is shaking his head. But I think that's kind of like, more for practical considerations. And there is an asterisk there, which is saying, like, unless we dramatically improve, like, our ability to manipulate embeddings and, like, how we can work with that. But for better maintenance or compliance, especially in, like, real world setups, I think, like, tight control is needed. And then I think we are not there with, like, embedding methods. So until those happen, like, I think graph structures are going to be there, in my view. And the other benefit is also, like, modularity, right? So the world is changing. Do you want to store all of those knowledge as, like, as in the parameters of your model? Or do you want to have some sort of, like, modular structure to kind of, like, separate the knowledge, certain types of knowledge in structure and others in parameters? But I think all of those are very interesting questions. So finally, I want to leave you all with a grand challenge of, like, how about we kind of like, focus on building a knowledge graph, not just for, like, 10, 20 languages, but, like, go all the way to 1,000 regions and 1,000 languages in the world, ensuring that there are, like, 500,000, 500,000 entities in each one of those regions, and not just kind of like build that knowledge graph, but also have some metric that tied to some important downstream task. Here I have just picked, like, say, cross-lingual QA. Let's say that, like, we have, like, say, 90% plus accuracy in cross-lingual QA in each one of these regions, right? So in order to do this, I think this is kind of, like, quite far off from where we are today. So, like, we have to address lots of questions about, say, community participation, how we can build more meaningful and inclusive benchmarks, and not just be English-centric, and how can we build more flexibility in the schemas. So again, kind of like, maintaining them in the real world is a pain, and then how we can, like, both these kind of neural models and structures could coexist, and what should be the division of knowledge between these two. And the list could go on. This is just like a partial list of questions that, like, hopefully some of you may find interesting. So I'll stop here, and thanks for your attention. And if you have any questions, I'll be happy to take it.